Okay, so today we're going to take notes on the atom, and I just need to do a little bit of review. So the first thing I need you guys to see is on our notes, we're going to write about the atomic theory. Now your note sheet, you're going to have just those lines filled in. Okay, let's go back to the camera. All right, so you're going to write down on the first dot or near the top, all matter is made of atoms. Okay, that's a review. We also need to know that the atomic theory explains what atoms look like and how and why they behave the way they do. The last thing that you need to write before we start looking at the pictures, yes, I know there are lots of dots on your paper. I don't know why I have so many dots, but this is the last thing we're going to write before we get to the picture, and that is, if you need to go back and look at anything about previous theories or previous scientists, you already have notes on that, so go back and look at those notes to remind yourself on those. At any time during class, if my video and I'm talking too fast and you don't get to write everything, ask my sub to pause the video and you guys can continue writing down and then the sub can start it up again, all right? So, now we're at the picture, and on the picture you can see I have us outlining the different parts of the atom. If you look at the top right, there's a dot on your paper that says under nucleus. I want you to write this statement down, that the nucleus is dense. You can see that it's positive, and that's where the mass of the atom is. The nucleus is made up of two parts. You have the word proton, and they have the word neutron on your notes, and underneath each you have different dots. So for the proton one, make sure you indicate that it has a positive charge, and that the mass is 1 AMU. Underneath the neutron, again, you're going to have no charge and a mass of 1 AMU. I want to remind you again, at any time during the class time, if you just say to the sub that things are going too fast, they will push pause on this video and you guys can continue writing things down. Over on the left-hand side on the notes sheet, you have the electrons. There are 3 little dots underneath it on your papers. So you want to indicate that the electrons have a negative charge. The mass is very insignificant, so that's why I say little to no mass. And that it's located outside of the nucleus, beyond the nucleus borders. But you know, this picture we have here isn't really all of what we need to be able to look at. The picture doesn't give us everything, so we're going to be looking into more about what the electrons are doing. So I'm moving to the next slide now. All right, so you can see that on your notes, the rest of the writing above the top here has already been written down for you. You don't have to write anything down. But on the picture, what we see is the nucleus and different rings. This is the first energy level, the second, third, and the fourth. And on the first energy level, what I'm letting you know is that 2 electrons can be held onto there. On the second energy level, it can hold on to 8. The third one has 18, and the last one maxes out at 32. These numbers are numbers that I need you guys to put to memory. 2, 8, 18, and 32. We're only going to go out to the 4th energy level. You don't have to worry about going past that. Okay, so underneath your picture, you're going to put down a lot of information about the valence electrons and energy levels. So your first one for valence electrons, you can see I want you to write down the electrons that are in your outermost energy level. Valence electrons can be in any energy level as long as they're the outermost energy level. Any energy level that can be the outermost energy level. And finally, the valence electrons are what gives elements their properties, the way they behave. If something is very reactive to water, it's because of its valence electrons. If something is very stable and does not react, it's because of its valence electrons. Then you can see on your paper you have the word energy levels and a couple dots there. So you're going to indicate that the energy levels are the rings that indicate how far or the distance electrons are from the nucleus. And the electrons can move from one energy level to another just by absorbing or releasing energy. And my example that I have is back when we were learning about Niels Bohr, and that if electrons get excited, it's because they have absorbed energy and that they've moved to a higher energy level. And again, that makes them slightly unstable, and then they want to release that energy. And after they've released it, they will then fall back to a lower energy level, and then they're considered stable. All right, again, remember, you can ask for a pause anytime. Moving on to the next slide. So I wanted to remind you about Niels Bohr. Like I was just talking about, he said that electrons would jump from one energy level to another, and that these electrons look like a solar system. So now we need to talk about how this relates to the periodic table, because we're going to be using the periodic table to find a lot of this information. All right, as we've been practicing for the last day or two, that the number of protons comes from your atomic number. So that's the first thing you need to write down about using the periodic table, is that the number of protons comes from the atomic number. And the second line is the number of electrons also comes from the atomic number when the atom is neutral, only when the atom is neutral. And since we've only been talking about neutral atoms right now, this works for us, but it will change when we start talking about atoms that are not neutral. The number of energy levels that an atom has comes from the period, or the row, and the number of valence electrons comes from its group that it's in, or the column number. At this point in time, I need you to have your periodic table out, and I need to show you some things with my periodic table and how that applies to you. Hi. Okay, periodic table. All right, so as you saw, I was saying the number of energy levels comes from your period or your row. So if you look at this part of the periodic table, right there it says period. These are your periods. So the first period, which has this one here, these all have just one energy level. This is your second period. All these elements going all the way across have two energy levels, 3, 4, 5, 6. And elements in this row have 7 energy levels of electrons. That's what we're talking about with period. So you can circle the word period, make a little arrow down like I did on your periodic table, because you will see that these numbers are there to indicate the number of energy levels you have. So whatever I write, you can write. The other thing we said is group. So there is where the groups are, and groups go across this way on the periodic table. And I said the group number is your column number, and that tells you how many valence electrons you have. Now the group number we want to look at is the group number that has the A by it, and these are very, very light, and they're all with Roman numerals, so we're going to write on top of that and change them from Roman numerals to regular numbers. So this is group 1A, so that's the one we want to look at. This is group 2A, so we want to look at that 2. We have to go all the way over to this side where boron is, and we're going to make this say 3A. Right above carbon, 4A. This is the Roman numeral 5, so we're going to just write 5A. This is 6A. This is 7A. And then this is 8A. All right? So all the stuff that I wrote on my periodic table, you want to have written on yours. So when you're looking at your notes again, what I had said is that your group number tells you how many valence electrons you have. So every one of these elements here have 1 valence electron. All these elements here have 3 valence electrons. All these elements here have 7 valence electrons, because they're all in the same column. All right, let's go back to our notes. So on your notes, the last thing we have to write down after we had finished putting all of the stuff about your energy levels and your valence electron is that reminder that when you want to know the number of neutrons, the way you get that is by taking the mass and subtracting from that the atomic number. All right, but you have to take the mass number, subtract from it the atomic number. All right, so I'm going to show you how this works with a sample element. You can see on my PowerPoint, nothing is filled in at the top picture. You will eventually have a picture with some information in. Underneath that picture in boldface are 5 steps, and you can see on your notes some of the steps have missing words, and we're going to fill those things in. As I hit enter, my statement is going to change color, and then we're going to see something happen to the picture. And so we're going to do this for, if you look over here, an element that's named potassium 41. Okay, that's the element we're going to working with is potassium 41. So if you need your periodic table available to you, all right, I'm just going to hold mine up. My periodic table, potassium is right there. And I'm going to make reference to potassium. I'm going to make reference to potassium right there and where it's located, in what period it's in, and what group it's in. So we want to have that piece of information as well as we do this. All right, so the first thing we want to do is draw a nucleus, and you can see I drew that up above. That circle is already in your notes. And we want to put inside that nucleus the number of protons. So we have to go to our periodic table, find potassium, look for its atomic number, and when you find the atomic number for potassium, you see that it is element number 19. So I'm putting 19 protons in the nucleus. How I got the number of neutrons is I took that mass of 41, back here, potassium 41, subtracted 19 from this, and that's how I got my number of neutrons, which is 22. So we put that in the nucleus first. Step 1. Okay. Step 2. Determine the total number of electrons. And remember, our total number of electrons will have to be the same as our number of protons. So in this picture, we're going to need a total of 19 electrons when we're all done. That's our number we want to keep in mind, is we have to have 19 electrons when we're all done. Step 3. Determine the number of energy levels and draw those. All right, so going back to your periodic table and finding potassium, we have to look at what period potassium is in. Is this a good spot? Potassium right there, it's in period 4. Right? So that means we need to have 4 rings. If you look at your notes, we have a lot more than 4 rings. So we will use the first one, the second one, the third one, and the fourth one. And all the rest of these we're not going to use. So you can scribble those out, because we're not going to use those. We only need to use those 4 energy levels. All right? So we would typically draw those on. And I'm only doing partial rings, not full rings, because it's just so much easier to do. All right, so that's where our last electrons are going to go. That's going to be called our valence electrons, because we're only going to go out 4 energy levels. So our 4th energy level is going to be where our valence electrons are. How many valence electrons will we put in that box? Well, the number of valence electrons is equal to whatever group number that element is in. Remember potassium here? It is in group 1A. So it's going to get 1 valence electron. And so we can put a 1 up in that box. And our last step now is to start filling in the rest of the electrons, starting with the first energy level and working out. And I needed to remind you guys that the first energy level will hold a maximum of 2, the second one will hold a maximum of 8, the next one a maximum of 18. I say maximum because you fill it up to the maximum until you reach your total number of electrons. Our total number of electrons we need is, I don't know if anybody said the answer, but it's 19. We need 19 electrons. We have 1 so far. So the first energy level can hold 2. That is now 3 of 19 electrons. The second energy level can hold 8. We now have 11 of 19 electrons. The third energy level can hold 18. We will not need to put all 18 in. How many will we put in if we already have 11 and we need to put 19 total? The answer is 8. Yes, it doesn't have, the second last energy level won't always be the maximum. The second last energy level won't always necessarily be the maximum that it can hold. All right? So let's do one more. If you flip your page over to the next page, you're going to see that We're going to do one together of arsenic, 75. What does that 75 mean again? I don't know if anybody's yelling it out. It'd be really nice if my sub sees that you guys are not dead to the world. But 75 is your mass number. The mass number is your number of protons and neutrons added together. All right. Step number 1 from the notes that we just had is to draw your nucleus. Oh, look at that. There's a circle on the page. And inside that nucleus, we have to put down how many protons and neutrons it has. So we have to find arsenic. And you can see that I have an arrow on your notes pointing to arsenic right there. Right? That atomic number is 33. So that means we're going to have 33 protons. And we will put 33 in the nucleus. And now we have to also do our number of neutrons. That 75 is my proton and neutron count. So I have to subtract 33 from 75. And when I get that, I'll get 42. And so that's how many neutrons will go into the nucleus. All right, so now we've finished step 1, which is drawing the nucleus and putting in the protons and neutrons. Step 2 is how many electrons do we need to put into this picture? Well, we'll have to put 33 electrons in because we have 33 protons. So right now I'm just putting a little tally over here saying, all right, I need to get 33 electrons into this picture. What am I going to do to get 33 electrons in this picture? Well, before I can do anything else, I need to know how many energy levels I'm going to have. So I need to see what period arsenic's in. All right, so if you look at arsenic, you read all the way across, you can see it's in period 4. So I will put 4 energy levels on. The next step is to put how many valence electrons are on that last energy level. In order to do that, I need to see what group it's in. All right, arsenic is in group 5A. There's 5A. That means I'm going to put 5 electrons in the last energy level. After we have those 5 electrons, we're going to subtract that from the 33 electrons. Oops, back up again. I guess I'm not doing subtracting yet. So we're going to have, that's 5 of my 33 electrons. So now I'm going to go back and start filling in my innermost energy level. My innermost energy level, the first one can only hold 2 electrons. So I'm going to put that in. How many electrons can the second energy level hold?
Hey.
Okay, hopefully somebody, you guys yelled 8. Yay! Okay, so that's 15 electrons so far. So I'm going to subtract 15 from 33. That leaves 18 more electrons, and it just so happens 18 is the maximum that that third energy level can hold. And so I'll have 18 electrons there. This is how you do a Bohr diagram. If you notice, I'm not doing complete circles around the nucleus. It just saves paper space to not do that. All right. So this has been an example of doing the Bohr model with neutral atoms. All right. So make sure you guys remember, and by the way, we're on the last page of our notes now, and this writing is already on your notes for you. The smallest piece of an element in which there is no charge is a neutral atom. The atom has the same number of protons as it does electrons. And so you can see in symbology form, I said proton number should equal electron number. All right, so I want to go through these steps with you guys on the last page. So if you could zoom in on my paper here. So let's practice this with some pictures. And you can see I have information about carbon, lithium, and sodium on here. And we'll also have to look at these things with respect to our periodic table. All right. So carbon, here's our nucleus. All right, so there's our nucleus. Inside our nucleus, we have to put our number of protons and our number of neutrons. Our number of protons is our atomic number, which is 6. The mass is 12. I subtract the number of protons from it, and I will get the number of neutrons, so I have 6 neutrons. I look at where carbon is on the periodic table. I read all the way across. It is in the second period, which means I need to have 1 ring, 2 rings. Notice the 2 rings are already drawn there for us. I go back to carbon on the periodic table. I look at what group it's in. It's in group 4A. 4A means on this last level here, I'm going to put down 4 electrons. I have 4 electrons, and because I have 6 protons, there's 6 electrons I need total in my picture. So this is how many I need. This is how many are on the last ring. This is how many are left. That's going to go on this energy level, 2 electrons. And now 2 plus the 4 equals the 6 electrons total. Lithium. Here's the nucleus. It's the inner circle that I have drawn on here. I need to do the number of protons and the number of neutrons. My protons come from the atomic number, which is this. This is the mass of my lithium, minus the number of protons gives me 4 neutrons. So I have 4 neutrons. Lithium on the periodic table is in the second period. So I should have 2 rings. This picture already has 2 rings drawn on it for me. Lithium is in group 1A. So this last energy level will have 1 electron. Because it has 3 protons, I need 3 electrons total. I've done 1 electron so far. That means 2 electrons have to be left. And so these 2 electrons will go on that energy level. That is the maximum that the first energy level can hold. Sodium. Draw your nucleus first. I have to tell the number of protons and the number of neutrons that I have in there. The atomic number tells me my number of protons. This is my mass. I subtract the mass from my number of protons, and I will get my number of neutrons. Now I need to know how many rings to have. Sodium is in period 3. I'll need to have 3 rings. This picture came drawn with 3 rings. I need to know how many to put on that last ring. I go back to sodium. I see it's in group 1A. That means there's going to be 1 electron on this last energy level. I need to have a total of 11 electrons. I've put in 1. Now I'm going to go to the innermost electron level, and that one can hold 2 electrons. So this is 3 so far. So I've done 3 electrons out of 11. 3 from 11 gives me 8 more electrons that I need to place, and that's what I'll put on my second last energy level, and it just so happens that energy level can max out with 8 electrons. All right, so this is me doing the example for you a couple of times. What you're going to do today, you're going to practice the same thing with a paper that looks like this. You'll notice that on every picture, I gave you guys the number, a nucleus, and a place for you to put down the protons and neutrons. You can see in every one of these pictures, just like on the sheet I just finished, I gave you the mass number and the atomic number. What I did not provide for you is what group and period it's in. So this box was provided for you so that you could get your periodic table out. And so we'll do the one for argon, okay? So you find argon, which is right there. You can read all the way across with argon that it's in period 3. Let's go back to argon right here. And it's in group 8A. So on the paper for argon, I'd write period 3, group 8A. And with this information, I should be able to do my full diagram of my protons and neutrons. I should be able to put down the number of rings I need and how many electrons in every ring. You'll notice that there are 8 of them on this page. Or sorry, 10. Let's try counting better. And when you flip the page over, there's a few more. All right, this is what I want you to do with the people at your table and practice for tomorrow. This video is on my website, and if you need to go back and look at the PowerPoint or the video, it is there for you. Plus, you have all the notes that you just took that I did as well. See, I took the notes. I just didn't fill this one in because I was talking, but I filled in these notes, and you saw me do this. So we have all these notes available for you to go back and look at. And this is what I need you to do in class time today with the sub, is to finish this worksheet. All right, see ya.